Old trucks are quietly becoming harder and harder to keep on the road in 2026, and most drivers don't realize it until they're already stuck in the system, facing a failed inspection, a costly repair estimate, or a retirement offer that feels too low to make sense. Across multiple states, a similar pattern is showing up. A truck passes every basic mechanical check, the engine runs fine, emissions seem normal, yet it still fails smog inspection. The reason often comes down to something most owners never think about: the OBD-II readiness monitors. If those internal self-checks don't report complete, the vehicle can fail automatically, even if nothing is actually wrong with how it drives on the road. That's where the frustration begins, because instead of a clear mechanical failure, owners are dealing with a digital system that doesn't always reflect real-world performance. A truck can be fully functional, reliable, and clean in actual use, and still be flagged as non-compliant because a sensor routine didn't finish in the expected way. And once that happens, the cost pressure starts building fast. In many cases, the only way to pass inspection is to run repeated drive cycles, replace aging sensors, or in some situations, repair or reprogram engine control modules that are decades old. These repairs can quickly climb into the hundreds or even thousands of dollars, especially on older vehicles where parts availability is limited or diagnostic time is extensive. At the same time, some state programs offer a different option. Instead of repairing the vehicle, owners are given the choice to surrender it under a vehicle retirement or scrappage incentive program. In return, they receive a fixed payment that is often far below the actual market value of a well-maintained older truck. On paper, it's presented as an environmental solution. Remove higher emission vehicles from the road and encourage cleaner replacements. But in practice, it creates a financial gap. Repairing the truck becomes expensive enough that the incentive starts to look like the easier option, even when the vehicle itself is still fully usable. This is where the system becomes less about direct enforcement and more about economic pressure. There is no official ban on older trucks in most cases. There is no law saying they cannot be driven. Instead, compliance is tied to increasingly technical inspection standards that become harder to pass as vehicles age. The OBD-II system is central to this issue. Introduced in the mid-1990s, it was designed to monitor engine health and emission systems through internal diagnostic checks. But those checks rely on specific driving conditions to complete. If a vehicle battery is disconnected, if codes are cleared, or if certain conditions aren't met during a drive cycle, the system may reset and report not ready. And when inspection day comes, that single status can trigger a failure. That means older trucks are not just dealing with wear and tear. They are dealing with the structure of the software itself. A system that was designed for monitoring can become a gatekeeper for registration, even when no real emissions issue exists. This is especially significant for trucks from the early 2000s, where electronic systems are far simpler and more sensitive to resets or aging components. As these vehicles continue to age, the probability of readiness issues increases, even if the engine itself remains strong. At the same time, several state-level programs have expanded vehicle retirement incentives. These programs vary by location, but the general structure is similar. Owners are encouraged to retire older vehicles in exchange for a cash payment, often combined with incentives toward newer, lower-emission models. The stated goal is improved air quality and reduced pollution from older engines. However, critics argue that the real-world effect is a gradual reduction in the number of usable older trucks on the road, especially in states that follow stricter emissions frameworks modeled after California regulations. Those frameworks influence multiple states across the US, meaning the same inspection logic appears in different regions. That's why similar stories are reported in places like New York, Washington, Oregon, and Colorado, where inspection outcomes and compliance requirements often follow the same structure. In this environment, the cost of keeping an older truck becomes unpredictable. It's no longer just fuel, maintenance, and occasional repairs. It now includes compliance risk, diagnostic uncertainty, and the possibility of failing for non-obvious software-related reasons. Another major factor influencing this situation is the broader direction of the automotive industry. Modern vehicles are increasingly software-controlled, with manufacturers relying heavily on proprietary systems for diagnostics and repairs. This has led to ongoing debates around access to repair data, independent mechanic capabilities, and the long-term affordability of maintaining older vehicles. As vehicles become more dependent on software, older models that rely on early versions of these systems become more difficult to service. Not because they are inherently unreliable, but because the tools required to diagnose and correct issues are more specialized and less accessible. When combined with inspection requirements, this creates a situation where older trucks can remain mechanically sound, but still struggle to stay legally compliant without investment. This is also where historical context matters. Large-scale vehicle incentive programs in the past have already shown how quickly fleets can be reduced when financial incentives are introduced. Programs that encouraged trade-ins of older vehicles demonstrated how economic pressure can move large numbers of owners toward newer models in a relatively short period of time. The long-term effect of those programs also contributed to a tighter supply of older used trucks, which is still felt in today's market. Fewer surviving older vehicles naturally increases demand, which increases value, but also makes compliance decisions more impactful for owners. So the current situation is not happening in isolation. It is the result of evolving inspection systems, expanding retirement incentives, and increasingly software-dependent vehicle design all moving in the same direction at the same time. For truck owners, the key challenge is understanding that failure is not always mechanical anymore. In many cases, it is procedural. It is tied to system readiness, diagnostic completion, and compliance timing rather than visible performance issues. That shift changes how older trucks must be maintained. It is no longer enough to ensure the engine runs well. It also requires ensuring that the vehicle's internal diagnostic systems are in a ready state before inspection. That includes understanding drive cycle requirements, avoiding unnecessary ECU resets, and keeping sensors in stable working condition. Because in many inspection systems today, a truck is not judged only by how it performs on the road, but by how it reports itself to the system. And that is where most owners get caught off guard. The truck may feel perfect in real-world driving, but inspection systems often operate on a separate layer of logic that doesn't always match on-road performance. As these systems expand, older trucks are increasingly caught between mechanical reliability and digital compliance, and that gap is where most problems appear. The rules are changing quietly through software-based checks and stricter readiness requirements, and most drivers only notice when something goes wrong. For owners of older trucks, understanding this system is now essential because it can mean the difference between a simple inspection pass, an unexpected repair bill, or even being pushed toward retirement programs. If this breakdown helped clarify what is actually happening behind these inspection systems, make sure to like the video and subscribe for more deep dives into how modern regulations and automotive technology are reshaping the vehicles we rely on every day.